a few properties of matrices that you need to be aware of. So let A, B, and C be matrices with the same dimensions, and let K be a scalar. The associative property of addition can be performed on a matrix. If I have matrix A plus matrix B plus matrix C, that can also be the same as saying matrix A plus matrix B plus C. So your associative property. The commutative property of addition also holds true on two matrices. A plus B, matrix A plus matrix B is equal to matrix B plus matrix A. So it does not matter the order that you divide or you add with addition. The distributive property also holds true for two matrices. If I have a scalar K times the sum of matrix A plus matrix B, I can distribute the scalar, and that would be the same as saying K times matrix A plus K times matrix B. And that also holds true for subtraction. So we'll take these properties and we'll apply them to an example here. Pet stores. Two pet stores sell both dogs and cats. Sales from each store for the last month and this month are shown below. So last month, store number 1 sold 42 dogs and 33 cats, while store 2 sold 56 dogs and 21 cats. This month, store 1 sold 36 dogs and 51 cats, and store 2 sold 48 dogs and 37 cats. Organize the data into matrices, then write and interpret a matrix giving the average monthly sales for the 2-month period. Now remember, an average is just a sum of all the numbers divided by your total amount. So keep that in mind as we solve this problem. First thing we want to do is set up two matrices that represent last month and this month. All right. So last month, we'll call that matrix A. We had the two stores, right? We have store 1 and we have store 2. And in store 1, there was 42 dogs and 33 cats. And then store 2 had 56 dogs and 21 cats. So the column represents your dogs. The first one is dogs and the second one is cats. Okay. We're going to do the same thing for this month now. We're going to set up matrix. We'll call this matrix B for this month. And again, we have store 1. We'll just go number 1, store number 2, and then we have dogs and cats. So that'll form our matrix. So we had 36 dogs and 51 cats, and then 48 dogs and 37 cats. And this is matrix B, by the way. So we've set up a matrix to represent each month, and then now we want to find the average for the monthly sales for this 2-month period. So to find the average, I need to figure out matrix A plus matrix B, and then take half of that, or divide it by 2. All right. So let's calculate this average. I'm going to go 1/2 times matrix A, which is 42, 33, 56, and 21. Plus matrix B, which is 36, 51, 48, and 37. So we'll start inside the parentheses. We'll add first, and then we will take half of that. So we're going to add the corresponding elements. 42 with 36 gives me 78. And then 33 plus 51 is 84. 56 plus 48 is 104. And then 21 plus 37 gives me 58. So we add first, and then we're going to divide by 2, but that's really the same as multiplying by 1/2. So we're going to take the scalar and distribute it throughout the matrix, and we will end up with this matrix. 39, 42, 52, and 29. So just go inside and take half of 78, 84, 104, 58, and this is what you'll end up with. Now, what does that mean? Well, the first row is store number 1, and then the second row will be store number 2, and then the first column is dogs, and then the second one is cats. So we can say that store number 1 on average for these 2 months sold 39 dogs, and they averaged 42 cats, while store 2 sold 52 dogs and 29 cats. So you can use matrices to find an average. All right, keeping those same properties in mind, we can solve a matrix equation. All right, so here we have 4 times matrix with elements 3x, 1, 0, and 6, plus matrix 1, negative 3, 2, negative 2y. And that's equal to another matrix. So we have a sum inside parentheses times a scalar should equal this matrix over here on the right of the equal sign. Right? So we're going to try to figure this out. First of all, I want to go ahead and just add the 2 matrices inside the parentheses. Right? So we've got 4, and then we're going to end up with a matrix inside. So let's add the corresponding elements. We'll go 3x plus 1 is just 3x plus 1. They're not like terms, don't put them together. 1 plus negative 3 gives you negative 2. 0 plus 2 is 2, and 6 plus negative 2y is 6 plus negative 2y. Or you could write it as 6 minus y. That'd probably be easier. Minus 2y. So that's what you have inside the parentheses when you combine those, and that should equal negative 8, 8, negative 8, and 0. Then we're going to take this scalar and we're going to distribute it inside the matrix. All right? So let's see what we get here. Now, you notice there's a 4 times 2 would give me 8, and then 4 times this 2 also gives me 8. This should have been a negative 2 also. 1 plus negative 3 is negative 2. So 4 times negative 2 is negative 8. And you'll notice that over here, we're saying that these 2 sides are equal. In our solution matrix, we also have negative 8 in the top right corner, and we have negative and positive 8 in the bottom left corner. So those elements are matching up. All right? So let's take 4, and we're going to multiply it times 3x plus 1 in the top. So think of it as 4 times 3x plus 1. You're just going to distribute. 4 times 3x is 12x, and 4 times 1 is positive 4. And then we'll take the 4 times the 6 minus 2y. So 4 times 6 is 24. 4 times negative 2y is negative 8y. And we have a negative 8 and a 0. All right. So again, negative 8 corresponds with negative 8, and 8 corresponds with 8. So what should 12x plus 4 correspond with? Well, that should equal 8, or equal negative 8. So let's set those two equal, and then we can solve for x. So 12x plus 4 should equal negative 8. Corresponding elements in an equal matrix, They have to be the same, so just set them equal and then we can solve. I'm going to subtract 4 from both sides. That gives me 12x equals negative 12. Divide by 12 and x equals negative 1. Right, so we know the value of x is negative 1. And then we're going to do the same thing with the 24 minus 8y. That should equal 0. So we'll set it equal to 0 and we'll solve. I'm going to subtract 24 from both sides. That gives me negative 8y equals negative 24. Divide by negative 8. And y is equal to positive 3. So the value of y is 3. And x is negative 1. We solved the matrix equation. Alright, here's another example. We've got pretty much the same thing. You've got two matrices being subtracted inside, and then that answer is being multiplied by a scalar, and that should equal this matrix on the right side. So let's go ahead inside the parentheses first, your order of operations, and we will subtract these two matrices. Subtract corresponding elements. 3 minus 1 is 2. Negative 2x minus negative 6 would be negative 2x. Remember, minus minus becomes plus 6. I have 1 minus negative 5y, which again, minus minus becomes plus. And then 7 minus 4 gives me 3. So we've started inside the parentheses, the order of operations. We combine those two matrices. Now we're going to multiply. I'm going to take 2 times all the elements inside. So negative 2 times 2 gives me negative 4. Negative 2 times 1 plus 5y. That gives me negative 2 times 1 is negative 2. Negative 2 times 5y is negative 10y. Then we'll go negative 2 times negative 2x plus 6. That gives me 4x minus 12. And then negative 2 times the 3 is negative 6. And that should equal negative 4, 8, 12, and negative 6. All right? So we're saying that the matrix on the left side is equal to the matrix on the right. If the two matrices are the same, then the elements must have the same value. And you can tell that in the top left corner we have a negative 4 and a negative 4. Those corresponding elements are the same. In the bottom right corner we have negative 6 and negative 6. Those bottom right elements are corresponding and they're the same. So how can I find the value of 4x minus 12? What's the value of x? Well, that thing should equal 12. Those two elements have to be the same. So I can take 4x minus 12, set it equal to 12, because they correspond, and solve for x. I'm going to add 12. So that gives me 4x equals 24. I can divide by the 4, and x will equal 6. So the value of x will be 6. That makes these two matrices equal. And then I need to find the value of y. I've got negative 2 minus 10y. And that should equal 8. So we'll solve for y. Add 2. So negative 10y equals 10. Divide by negative 10. And y equals negative 1. So my value for y is negative 1. The value for x will be 6. And there's a couple more examples. They are just like what we did. So I think that should be enough to help you get through the assignment.